Okay, this is Sean Carichner's projectile motion example. So the problem is the Red Sox were 3-3 with the Mets. A Red Sox player hits a fastball at 42 meters per second, 30 degrees from the horizontal. If the height of the bat where the ball was hit is 1.5 meters and the ball lands 155.779 meters away, what is the ball's max height? The first thing I always like to do is draw a picture. So we know that the total initial velocity is 42 meters a second, and the angle from the horizontal is 30 degrees. So it looks something like this. We also know that the ball is hit 155.779 meters away, and the height that the ball was hit was 1.5 meters above the ground. So we're going to split our horizontal and vertical components up from the total velocity and the angle. If you remember SOHCAHTOA, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent, then this should be pretty easy. So vertical components will be y and horizontal will be x. So this one's our vertical right here since it's y. And the reason you use sine is because sine is opposite over hypotenuse, and we're trying to find the opposite side from the angle. And it's the other way for the horizontal. So essentially what this is saying is that the vertical initial velocity is 21 meters a second and the horizontal initial velocity is 36.37 meters a second. A thing to remember is that horizontal velocity does not change. It has no acceleration, but vertical does. So this is the things we know so far. We know that the vertical initial velocity is 21 meters a second. We don't know the vertical final velocity. We know that the acceleration for the vertical is negative 9.8 meters a second squared. We know that both the initial and final velocity for the horizontal is going to be the same because it doesn't change, doesn't have any sort of acceleration. So it's going to be 36.37 meters a second all the way. So we're going to use the horizontal component to find time, and in order to do this, we have to manipulate our equation for displacement. We're going to get rid of the acceleration side because the acceleration is 0. And we're left with VIT. Now, since we don't know the time, but we know both the displacement and the initial velocity of the horizontal, so like this, we can use unit analysis to figure this out. And the time comes out to be 4.28 seconds. But we aren't done yet. So far, we've filled mostly everything in. You don't need to fill everything in, just anything sufficient for the problem. So now we're actually going to find max height. So we're still going to use the displacement equation. We're going to use x equals VIT plus 1/2 AT squared. And since we actually know everything here and there's an acceleration and everything, we have to use the full equation. Can't leave anything out. So the vertical initial velocity in this case is 21 meters a second times the time, which is half of 4.28 because we're trying to find the max height, which is at half of the parabola. So we do a bit of unit analysis, and one thing to also note is that going back to the actual problem, it said the height of the bat when the ball is hit is 1.5 meters. Well, we just add this to what we got for this. And this is our max height. That's it.